At Service Logic, we believe the future of the skilled trades lies in training and development, and that's why we created the Edge, a platform dedicated to empowering our greatest assets, our people. From hands-on training to leadership development, Edge is where technicians grow their skills, expand their opportunities, and build lasting careers. Because when people succeed, our companies, our customers, and our industry thrive. This is the Edge. This is the future of the skilled trades.
I chose iConnect training equipment because I already previously had some iConnect training equipment. And I was very pleased with the equipment I had, the quality of it, and pre-designed labs that came with it. So when I expanded it more into the catalog, I decided I wanted to get this refrigeration trainer in my program to expand my program. My experience so far using the TU-155 has been pretty good experience, especially my second year students, and the light bulb kind of syndrome goes off when you see that little flicker in their eye and they're, oh, I got it. That's what us instructors, what we look for is the I got it moment. And this helps me to the I got it moment with my students, and that's what's my goal to achieve.
We are Daikin, the #1 global indoor comfort provider. Our innovative home and building solutions are engineered with energy efficiency and sustainability at their core, ensuring improved indoor air quality for all. From heating and cooling to ventilation, air purification, refrigeration technologies, and connected devices, we're at the forefront of technology, addressing the pressing challenges of sustainability.
Hello, our beautiful HVAC community. Thank you all for joining us this wonderful afternoon. We're spending some time today diving back into a topic that Sam and I really, we brought on the show. We were sitting here thinking about that. It was like episode number 8. We're at like 192. It's been quite a while. And when we were doing the demo, we had so many educators reach out going, hey, I got to learn more. It's something I didn't use out in the field, and it makes so much sense. I need to learn more. And it's been a little while. So we wanted to reintroduce the topics, talk about like what happens when we find things wrong with a home. Where do we fix things? What do we begin looking for? We're so grateful that you're all joining us. Scott, you're really going to enjoy this one. This is a very intriguing topic because as a technician, I spent most of my time on the service sector. Now, I did installations. We did some, for quite a few years in my career, we did custom designs and installs, but I wouldn't say that I was great at building science. The beautiful thing about spending time with fellow educators and instructors in our industries, everyone is here to help. Like we do this show. We're getting ready to approach 200 episodes of bringing in the top instructors from our industry to help us all become better. I was actually just talking to Sam. You'll appreciate this. Sam Myers is with RetroTech. How's it going, my friend?
Hey, happy to be here. Thanks for having me.
You and I were talking earlier about an OEM that had reached out to do some OEM training classes for their contractors. And just a couple hours before the show, I had a phone call from my good friend, Matt McKinney. And he says, hey, Sam's going to be on the show. I can't wait to be here. So hopefully Matt's joining in today. And what he was sharing was the same kind of thing that we're hearing from the industry. Not a lot of contractors, definitely not a lot of educators are comfortable enough to be able to do blower door tests, let alone understand what some of those results mean. That's really what we're going to do here today. And Todd is joining us because this actually is one of Todd's very comfortable components of his experience. And so by bringing in different talents from the industry, we all get to learn, because I'll be honest, I have been like on virtual calls with Sam, went through the entire blower door testing. I have never actually done a blower door test myself. I've never touched one. And so we're just talking, that's going to have to change. And so all of the educators that are joining us today, let us know in the chat, are you currently teaching blower door testing in your programs? And if not, allow us to help you. Allow us to bring you to a place where you have all the resources that you need to be successful. Because Sam, you're starting to see a growth in contractors, in particular young technicians, looking for training on this. And is that fairly new, do you think?
Yeah, I don't think it's new altogether, but it's definitely picking up. Like we're seeing like a higher level of frequency there. And I think, where it's coming from is, one of the questions that we get is like, when is it appropriate to do that? Right. Because I don't need to do a blower door test on every visit that I go to. But at what point do I say, okay, maybe it's time to look at this? And I think as more and more HVAC contractors and educators have approached us, we're seeing more and more just frustration in the field. Like, okay, I've run through everything that I know to do, and I cannot solve this comfort problem or this humidity problem or this indoor air quality problem. What's next? Like they're starting to realize there's more pieces of the puzzle. It's just, what are they and how do I find them? And so that's where we really kind of start to think like, okay, the HVAC system itself, you've done all your checks. It looks good, but the container that's holding in all of that conditioned air, we haven't looked at that at all. And that's equally important. And so that's kind of how I try to teach it a little bit. It's like, okay, well, if everything mechanically is sound, let's make sure that air is staying in and air that we don't want to come out is staying outside. And so there's some steps we can do before we go in and do a full blower door test. Like, for example, we make a high resolution manometer that auto zeros that's not a blower door manometer. So that way you're not using a $2,000 gauge to do just some spot checks on a house. You can use this, $400 gauge instead, and just put the house through the motions, reference it to the outside, turn the HVAC system on. If the ducts are located outside of the building envelope, does it go positive? Does it go negative? If so, how much? Do things change when you open and close bedroom doors? Are bedrooms themselves positive or negative to the rest of the house? So you can look at all of that kind of without a blower door, just to kind of see if things are out of whack or not. And then that can tell you like, okay, blower door test makes sense, or maybe not. So there's ways to kind of break some baby steps into the pool without having to cannonball into it.
Well, and that's the goal. We have to start somewhere. Scott, I truly appreciate you. This is sharing our vulnerability, right? As instructors and educators, it's not easy to say, I'm not teaching this, but I want to learn how, and I want to do things right. Like I've said it many times, and I will say this continuously. I didn't learn how bad of a technician I was until I started teaching. And I started surrounding myself with minds like these who have that experience and are willing to share and teach us the things that we all need to know to be able to do this correctly. And Garrett, that's part of the reason of doing this is understanding airflow, not just that airflow, because all of our students, all of our technicians, right, they can understand air moving through the ductwork because they've been around it all their life. But what about the air moving in and out of the structure? Like, how do we even know what we're looking at, and how do we test that? And that's what all this comes down to. Understanding the structure as a whole. Matt McKinney was sharing with me from Carrier that the experience he had was in his own home, where he had a system that he knew was probably oversized. It was a 3-year-old system, had many technicians out from a couple of different contractors. And finally, one contractor said, let me send one of my technical trainers over. And he brought his RetroTech blower door tester to the house, right? We're talking to someone who knows HVAC equipment, can teach you most things you would ever need to know about an HVAC system. But kind of like myself, didn't understand all of the dynamics of air movement within the home. Put the blower door test on and immediately found a significant amount of hot air and humidity coming down the gas fireplace chimney that he never used, and didn't realize that there was no damper inside of the thing. And for 3 years has been dumping hot, humid air into this fairly efficient home with very, very efficient equipment. But it took the blower door to be able to actually understand the dynamic of that vessel that you had mentioned.
Yeah, I kind of had a similar experience in my own house. We bought the house that we live in right at the beginning of 2020, built in 92, code built house. I mean, just kind of going through it during the due diligence period, I could tell it was going to be a bit of a basket case, and there were some bad decisions made in the past 30 years. But I was up for the challenge, and we've just now kind of gotten it to where it's behaving itself. And when we did that first blower door test, it was I think 7.8 air changes per hour at 50 Pascal. So for reference, a lot of codes today are requiring around 3 or 4, depending on what state that you live in. 3 is a pretty decent house. You want to try to get it as low as you can and then add mechanical ventilation. That's the goal. But 7.8, it doesn't really matter what you're going to do until we fix that. We're going to continue to have high humidity. I live in the Southeast, so high humidity is a big concern here. Comfort problems too. We had, rooms were kind of having temperature swings throughout the year and different from other parts of the house. And so we just did an attic encapsulation. And the other thing too is I replaced my heat pump knowing I was going to do some air tightness on the house. And so last summer it was undersized. And so finally, when we got it done over the winter, it's now keeping up and kind of right there where it needs to be. But just being able to have comfortable rooms, and we installed an ERV along with it too, because at that point, having some fresh air is a good idea. We just got the ERV going maybe middle of last week. It's maybe been running a week, and I'm sleeping better. Having that combination of just a tighter envelope, it's good, clean, filtered, fresh air, keeping humidity under control. Now we can make it do that. Before there was just no way until we tightened the envelope. So, I mean, after actually living through that myself, I mean, it's huge.
Yeah. And David, Harold, I'm so glad that you're here. I can't wait. I've been trying to catch up for quite a while on a completely different, intriguing topic that I can't wait to bring onto the show. It really is a component of our entire conditioning system. Remember, we're in the business of moving heat and conditioning air, right? That's our job. That's our career path. And it can look different around the country, but infiltration looks the same. So Todd, let's share with everyone a little bit about like the California side of things, because there's actually a whole lot of blower door testing and regulations that happen around that in your area.
Right. So, alterations versus new construction. Of course, new construction is going to be required to have a mechanical form for envelope, in this case, a blower door. I'd like to go back and talk about, a little bit about how you teach it. I usually start with the duct blaster first and then transition into the blower door. The ducts are technically part of the envelope, depending how they're, where they're at and everything. Of course, they might be out of conditioned space, but the internal parts of the ductwork are part of the envelope. So I start there and work towards the blower door. But with Title 24, California set the bar, right? California, New York. And of course, now that was Title 24, but then there's resident, right? And that's mostly the greater western coast, western United States rather. And, resident's also standard ANSI 310 is what resident is. And with that, they're making these standards. And every time a new code cycle comes out, every 3 years, the noose gets a little bit tighter and noose gets a little bit tighter. And to Sam's point, we want to get that building envelope, below that 3 air changes per hour. I'm sure, Sam, we got some calculations to go over with the air changes per hour and how that's calculated. But a lot of experience with that.
Okay. So for those that are joining that may not know anything about a duct blaster or a blower door test, let's kind of start from our fundamentals of what we're doing with the equipment, Sam.
Yeah, so whether if you're testing a building envelope or testing a duct system for air leakage, the components are very similar, right? So we're using let's start with the blower door, right? So there's 3 main components there. You've got a calibrated fan that'll have a variety of different openings, and the leakier the house is, the more open the fan will be. The tighter the house, the more choked down that opening will be, because you have to have the blade spinning, at a certain speed to generate a pressure to take your reading. So you'll see that when you look at the fan, you'll see there are these different hole configurations that you can have. The other main component is the manometer, and it's not your typical HVAC manometer. It's what we call a 2-channel manometer. So it's actually 2 pressure gauges in one housing. So one is reading that fan pressure, and then the other one is reading the building pressure. So when we do a blower door test on a house, we'll always test it to 50 pascals of pressure. which, compared to what you're used to in inches of water, that's a very small amount of pressure. But for a whole building, it's quite a bit. So it turns out to be about a 20-mile-an-hour wind hitting all 6 sides of the house. So
Ooh, there's a good
it's
reference.
yeah, so it's, not too much pressure to where you're going to mess something up, but just enough to allow you to kind of get consistent readings from house to house. And of course, the last piece of the system is something to block off the rest of the doorway. So there, in that picture, you see that red panel. So that's the most common way to do it. There's an adjustable aluminum frame that you can piece together, fit it to the doorway, and then put that red cloth around it. Fan fits in it. There's a spot for you to hang the manometer to kind of keep everything neat and together without anything sitting on the floor. But there, right there beside it is what you see as the duct tester. It's also a calibrated fan, just smaller. And instead of hooking up to a doorway, we're hooking it up to a duct system. So most of the time, we're going to be hooking that up to the return side. On our flange that goes from the flex duct to the fan, it's clear, has a couple of hooks on it. So if it's in the ceiling, you can just hook it on the ceiling and then tape off the rest. And to seal the rest of the system off, we use what's called a grill mask. It's a tape. It's kind of like a saran wrap on steroids. It's sticky enough to stick on to do an air tightness test on the system, but it shouldn't take paint off. If the paint's really brittle or if it's fresh, I've had to take it off a little bit sometimes. Sometimes it's smart to kind of maybe mask it off a little bit with painter's tape if you're worried about that. But there's other products you can use too. Like Vent Caps makes these reusable caps that you can use in lieu of the tape. But we're pretty much doing the same thing. We're just using that calibrated fan to get the system up to a known pressure. Houses, we do 50 pascals. Ducts, we do 25. And so it's what a duct test is. It's not replicating how that system would leak in real time. Because in reality, a duct system is going to leak differently in different parts because our static pressure changes down the line. Here, we're getting a uniform pressure. It's getting 25 pascals throughout the whole thing. So that's how we're able to measure that. And the way we interpret that for a duct system is it's a percentage of the floor area that HVAC system serves. So you may see a code require 4% leakage. So if it's a 1,000 square foot floor area that it's serving, so you're looking for 40 CFM or less at 25 pascals. So,
Okay.
But the manometer can do all that for you. Back in the day, before we had digital manometers, we would have to do all that math by hand. Now, if you know the area that the system serves, you can enter that in the gauge. For a blower door, we look at air changes per hour. So if you know the volume of the house, you can enter that in the manometer. It'll give you the air changes in real time. So it's really come a long way from what it used to be. It used to take a long time to do one of these tests and just kind of figure out the math to get that final result. Now, I mean, you can knock it out pretty quick.
That's one of the questions and concerns that we get from a lot of educators and contractors is I would like to do things right, but it takes too long or it costs too much for the equipment. Well, we take an example of, say Matt McKinney's project where we had a 3-year-old system that actually just failed. So now he's having to relook at a replacement system. That investment, one bad installation, and you've lost enough revenue to actually pay for one that will work for years and do hundreds of jobs. And so looking at it from that perspective, the problems that you can solve, but really is incomparable to the amount of return that you have on doing things properly.
Yeah, and I look at it too, like especially for those of us on the eastern half of the United States, where we get into humidity, you can really get into some serious health concerns if things aren't done properly. I had a client that I worked with beginning of this year. They knew they were pretty sure they had some mold growth somewhere in the house, but they couldn't see it. And they had a 1-year-old that was having some issues, skin irritation. The mother was the same way. They were having some respiratory problems. They had a mold inspector come in, which can go either way. This one used, they had a mold sniffing dog. And cool. When she talked to me, she was like, yeah, the dog just kind of sniffed in random spots. And so when I went to the house, where she pointed out, it was under a supply vent every single time because they were in the ceiling and the dog would sniff at the floor.
Really?
It's like, that's interesting. And so the system was sized appropriately. This was a fairly new house. It was only 3 years old. And I get up into the attic, and it's a single stage system that has 2 zones. And one zone is calling for the majority of the time. And so pretty much what's happening is they're cutting off half of that ductwork. And the other thing too is, this is Eastern North Carolina. So of course, all the ducts are outside of the enclosure. They're up in a vented attic where it's hot and humid.
You bet.
They used a supply plenum that was, had interior porous insulation, and it grew a farm in there, just because it was building up so much pressure. It was getting below dew point, condensing inside of there. And so once we were able to, we were able to use our high res manometer to see, like, when the bedroom doors were shut, some of them would get up to 10 pascals difference, which is a lot. You want to stay, like, for a new house that's like relatively tight, like that window is between like 0, 3 is like the highest you'd want to be. But the goal is to be as close to 0 as you can. So we were able to put in some room returns there to help balance that out, because when we shut all the bedroom doors, we would then reference the manometer to the outside, and the whole house would be -6. And so it was just actively pulling in hot and humid air from wherever it could when they shut all the bedroom doors. So those would go super positive. The rest of the house would go super negative. So once we fixed that, we also put in an EWC zone system that was based off of static pressure. So that way it would have a way to relieve any excess pressure and bleed off into a zone. Last time we spoke to the homeowner, they looked and sounded great. A lot of the symptoms have gone away. And so when you kind of get into stuff like that, you got to think about, like, how much is it for your quality of life? And what are you also spending in medical bills from your house that's making you sick? And so when you're getting into stuff like this, it's, a blower door test and some other additional diagnostics on the envelope is minimal compared to what you could be getting into if you choose to live with that.
We think about that contractor that's been servicing that home, right? System sized properly. Probably every time that they're there, middle of the day, all the bedroom doors are open, right? System may be operating properly. And without actually having the ability to measure what's happening to the structure, you're really just guessing.
Exactly. And knowing what questions to ask too, because that's one of the questions that I asked. Do you guys sleep with the doors open or closed? And her answer was closed. We always sleep with the doors closed because if there was a fire, we hear that it's safer. Like, yeah, I mean, that's completely logical. So, like, kind of knowing that and just kind of understanding the physics of how a house behaves when you start sending air places, does that air have a way to get back? Is it going to cause problems in another part of the house? So these are the kind of things that we look at. And so at the conference next year, we'll have our Madhouse simulator to kind of show that on a tabletop. What happens when you open and close the door? What happens if you don't have a return air pathway? What does that manometer show? What does that physically mean for the occupants? So, wow. Yeah, there's ways to teach that.
And that's really what we're trying to do, is to be able to show instructors and show to contractors, the benefit of understanding what these homes are doing. Because as we continue to make more efficient homes and tighter homes, there's consequences to that. And so what we're doing now is we're using tools, we're using instrumentation to just understand what's happening with the air flowing in and out of our structures. That's really all we're doing. We're used to doing this with ductwork, understanding what airflow looks like. We all know what happens when we have registers that close, returns that get dirty. But when we start thinking about the entire structure, sometimes we have to step back for a minute and re-look at, what do I know? What do I understand? And now I'm just a matter of getting the right tools for doing that.
Yeah, and I think sometimes it helps too, just to look at the rest of the house as just an extension of that ductwork that you're already looking at. Like when that air comes out of a supply register, that's not the end of its journey. So, like, what's it doing after that? And that's basically what we're doing, is just kind of completing that circuit to be able to look at the whole picture.
All right, so let's talk about a proper procedure. Either one of you want to hop into this one, because if we're an instructor and we're like, okay, I got the budget, we're going to invest, we're going to buy a full kit, and what room am I going to use? What structure am I going to teach in the classroom? Where's good places to start thinking about this?
Yeah, so from a teaching standpoint, if you're teaching this in a classroom, you've got some options. We make this tent. It's called a house simulator. And all it is just a little volume of space that you can set the blower door up into. But you can also make your own. That's what I'm actually sitting in right now. In my lab, this is an 8 by 10 foot tall structure that I'm able to set a blower door up into. I can add leakage, take it away. I can have different chambers. I can simulate a vented attic or an encapsulated attic. So if you do something kind of custom like that yourself, it may give you a little bit more flexibility. But either way, I mean, as long as you have something, some volume of space you can hook it up to, then you can actually simulate that stuff in a classroom setting. It's not all that difficult. Once you get a few of these tests under your belt, you can, from having all the components and their cases and their sleeves, you can have it up and running in about 10 minutes. So it's not bad as far as setting it up and teaching it. But, I think along with just the processes on how to set it up and run it, the sequence of events is important too, right? We're not just setting up the equipment. We have to set up the house too, right? So if we have combustion appliances, we want to make sure they're set to, off or pilot, because we don't want to backdraft anything. We also want to make sure that any windows are shut and latched. I had a client that I was helping out last year, and every time I went to the house like 3 or 4 times. Every time I went over there was like some different windows that were open. I was like, yeah, if you don't shut these, you're gonna keep having a problem. But yeah, I had to go check every single window in our house because I knew something was going to be open, and so that's just really important, because that's just not leakage that you want to count in your blower door. You want to make sure they're all shut and latched. Yeah, and after the house is all good to go, after we've checked everything out, putting the frame together, getting the cloth on it, setting the fan in it, getting your manometer set up, making sure you're reading pascals on channel A is what's going to give you your building pressure. Channel B is what's going to give you your airflow. So it can be CFM or air changes per hour. But the one thing that I feel like a lot of people forget about is there's this thing that we have to do before we turn the fan on called a baseline reading. And so that's going to help remove any effects from wind that's happening outside, or maybe any stack effect that's in the building, pressure that we don't want to count. And so it's like, if you're going to weigh something on a scale, it's like zeroing out the scale first. That's kind of what we're doing with pressure with a baseline reading. But, we have an app now that's built into our manometer that kind of makes you do that. It walks you through that sequence. It takes in all the information about the building, the square footage, the cubic footage too for the volume. It's like, okay, we're going to take the baseline reading. Here we go. Cover your fan. And then it's like, okay, now we're ready to run the test. Hit go, automatically runs it, makes a report. So it's easier to do it now than it's ever been.
Well, that's one of the things I wanted to bring up, because Scott had even mentioned, and it's the same thing that I hear often, right? It takes a long time. And Todd, back in the old days, started dating ourselves a little bit. Was that a case?
Yeah. I mean, it's interesting because I hear a lot taking the investment on the tools. Well, if you make the investment on your training, there's a lot of places, entities that are lending libraries. So if you wanted to get a custom, you get the training first, of course, and then you can go and rent out some tools.
Right.
Get familiar with them. Hey, maybe I want this brand over that brand, or I want to test the different ones out. And that's how a lot of places, and I won't name any names, but
no, I can, because I've done some training for them. So if you're on the West Coast, Pacific Gas and Electric, they actually
California
loaner, blower door, and duct blaster tools to be able to.
That's really cool.
So,
yes.
Yeah. So we're starting to see energy utilities recognizing the importance of this, and it's something that we have to be able to start teaching in the classroom, so that we can keep up to date with the changes in our industry. When our utilities look at a building and understand that I'm giving a rebate for high efficiency equipment, and hopefully this high efficient equipment is going to be installed properly, it's going to be commissioned, but what is the actual building doing? And is there things that we can do other than the HVAC to help improve the efficiency of the structure? And sometimes it's pretty minimal stuff. If you think about like that damper that was in the fireplace, things that may have gotten overlooked because may not be exactly HVAC, but can be a huge contributor to the efficiency of a home. And that's things we're looking.
Something I want to go to before we go to our slide deck, Clifton, is, you had asked our Sam how he taught it, and one of the ways I taught it was taught home performance, that is, duct blaster, blower door, airflow, etc. Kind of centered around Title 24 and nature of being California. Is we took an old shed. We got an old shed and we made a test house, a miniature test house. 10 by 8. Put a 1.5 ton air handler in it with everything. We basically made there are some trainers up there and in our headers up there that make these and basically make a test house, and it's a test house on wheels.
Yeah, that's awesome. That's the way to do it.
And so my students that year got to learn about building components, and we actually made this. We cut holes, put a window in, and
that's really cool.
Awesome.
Yeah, and then you can put a damper in too, and so you can show the difference between pressurizing and depressurizing. What changes when you do that?
Well, we put gate valves in on like some 4-inch pipe, and we opened them up and closed it because this is only a 10-foot by 8-foot building, so it didn't take much.
Exactly. That's another great idea. I've actually seen a building here at one of our local Ivy Techs in Indiana that is, it's designed to be able to show basic constructions and show the effect of different building materials. And I see that as a perfect opportunity to be able to teach blower door and duct blaster.
Yeah.
On that. Fantastic. And I should have gotten with you beforehand. You don't happen to have any slides on showing people like proper procedure, do you, Sam?
Oh, I can pull some up real quick.
I grabbed up the website. I didn't know if there was any videos that we wanted to walk through off from there. I know there were a couple on this one.
Yeah, if you actually go to the very last one there, I think that's actually, oh no, that's a full webinar. Go to the one before that. Okay, that's how to run a blower. That's a lengthy one too. We have some video quick guides on both the blower door and the duct tester. But I can also pull up.
Yeah, I was just sharing off from the screen. Anyone have any questions while we're grabbing a little bit more content? It's a good opportunity to ask any questions that you have or make connections to Sam while we're here. So I know you guys do a lot of training. I've had a lot of educators go through training classes. And like Sam had mentioned, we're actually going to be doing more of the education at the National HVACR Education Conference. I encourage everyone to spend a little time learning about what's happening at the conference. It's going to be a big year. We're going to be doubling in space. We're going to have a lot more of the hands-on style classes. And we're really looking forward to having everybody join us for that this year. I'll put a link here in a little bit to make sure that you've got access to that if you haven't been to the registration page to start looking at, booking hotels and getting your flights ready for that. Because it's going to be a pretty exciting year for sure.
Two things.
Yeah, we always have a blast.
Two things, Clifton.
Yes.
First off, where are we at with presenters? Do you want to make an announcement to have some presenters come? And second, the second question, Sam, is there any educational opportunities for schools for discounts on tools with schools?
Yeah, we work with schools for and provide discounts all the time. So if that's something you're interested in, you can just reach out to us at sales@retrotech.com, and we can definitely work with you.
That's awesome.
Put that in here too.
And then
sure.
And then back to that, Clifton, while you're getting that set up, it's my understanding that we're still looking for some last minute presenters. There are some spots open. Is that correct?
Yeah, absolutely. And so I know Sam was just saying he got his put in last night. For those educators, instructors going to be joining us, looking to share education with the rest of the industry. It's a fantastic opportunity to get in a classroom and spend time with your peers and share the things that you have learned along the way, like understanding high performance homes and understanding the equipment that is going in those and ways that we can make our structures more efficient. So be a lot of good classes there for this year.
Mm-hmm.
I haven't seen any questions come through.
All right, let's see if this will let me share here.
Okay. Give us all just a second as we get this loaded up. And for those that could be in the area next year, I'm actually out in the studio doing last minute preparations, getting the mobile studio ready we're going to be headed to the United Association International Training Program next week that also has the apprenticeship competition. So we'll be in Ann Arbor, Michigan for the entire week, Monday through Friday. So if you're in the Michigan area, or if you're a UA instructor, you're going to be there, get a hold of me. We'll set up some times to do some podcasts, do some interviews, and just spend some time together. It's going to be a great week. We'll have a lot of instructors that are there for education, learning about the building sciences, learning about new technologies like heat pump water heaters and high-performance inverter-driven heat pumps. So be a lot of education going on. A lot of our team members will be there doing classes. The following week, we're actually going to be doing a installation series for the entire week, and we'll be doing live from the location. So we won't tell you any more about it until we're actually on location. And I'll have a lot to share about that.
Yeah, so it looks like I will need to reboot my computer for this security to allow me to share. Sorry about that, guys.
That's all right.
Yeah. But we do have some pretty awesome videos on our YouTube, quick guide stuff. So we actually made these videos step by step. And if you have one of these, they're actually in the manometer too. So there's a resources folder where if you click on it, we made these videos in sections so that if you're out in the field and you maybe forget a step, you don't have to watch this lengthy video or find a section. You can just find what you want. So for example, setting up the house, that's the first one. Making sure those windows are shut, those combustion appliances are accounted for, then how to get the frame together, how to get the cloth on it. So we broke it up so that it's easy to track and just find specific parts that you're looking for.
And so you'd be start with like the blower door 101.
Yeah, so that's actually a webinar that I gave early. I think that one was earlier this year that just kind of goes into the basic mechanics, how to get the results that you need. So just a little bit longer presentation form on how to do that. But I think if you scroll down into playlists, there's video quick guides. There we go. So that one I think is, yeah, so that's just navigating the blower door manometer. I think the second one down is how to do a full blower door test. So as you have that manometer, you kind of have digital versions of me packed in there to kind of show you what to do, how to hook everything up, how to get the results that you need, what goes where, how to navigate the settings. To get those automated readings, you can get that live ACH 50 result in real time, how to do that and make sure that you're referencing the right numbers and everything. So we actually have all those resources built into it.
That's very cool. So yeah, I'd encourage everyone to spend a little time, do some research on the videos from RetroTech, and let's talk about some ways that we can connect with RetroTech, Sam.
Yeah, so our tech support team is just awesome. These guys have been in the field and done it. We're constantly in the field working with clients all the time. So if you have just basic, even just building science questions that might be outside of stuff that we make, you can just either email or just give our tech support team a call. If you just go to retrotech.com, the numbers are right there at the top of the page. And you can also just reach out to me directly. My email is just sam@retrotech.com. I am answering slews of building science related questions all the time. That's what I'm here for. And so as well as connecting you with training, or if you're looking, to maybe work with BPI or something like that too, we can tell you who we know near your area, maybe to help you out there too. So, yeah, we're always happy to help in any way we can.
Excellent. All right. So let's talk about some of the things that we can do. Like, let's just say that we're doing a blower door test and we find, say you had, 7+ air exchanges. Where are we going to begin? What kind of things can we be looking for as we begin our investigation?
Yeah, so like the first thing that I always try to make sure of is like, okay, is this the actual result from the house, or did I miss something? Yeah, so make sure you actually got all of those windows shut, that there's no connection to the outdoors that you could have closed off. The other thing too is just kind of paying attention to how the fan behaves. Like, for example, if it's running and then all of a sudden it jumps and starts to run even higher, maybe you pushed an attic door open or something like that too. So a change in pitch or a sudden change in flow can tell you a lot about what's going on too. Or maybe you stepped on a tube or something like that too. You always want to make sure you have your tubing kind of out of the way so that doesn't happen. But if I've done all that and I've made sure, like, okay, that's what it is, sometimes it just depends on the structure. Most of the times, I find that most leaks in a house are at the top and the bottom. Attics, vented attics leak a ton. Not only do you have penetrations for light fixtures, can lights, things like that. Anytime that you have your sheetrock butt up to an interior wall right there at the top plate, I mean, that's a crack on both sides that connects the living space to an attic, and that adds up to be quite a bit. That was actually the bulk of what I had going on at my house. And then also what I see throughout the country are knee walls just not addressed properly. And so that's when you have a living space, maybe a bonus room or something like that, and then attic space adjacent to it. And so you have that knee wall in between. Those almost always leak like a sieve. And so I would check there. So you can kind of verify that in different ways. Like, is this a problem or not? After a while, you kind of look at the details and say, yep, that is not blocked off. I can tell that's connected to the attic. Other ways, you can take another high-res manometer with one of our probes and just kind of get into under a baseboard, and are you seeing something?
Smoke pencil too.
Yeah, like a handheld fog generator is another way to do it. Especially if you can get in on that attic side and shut the door behind you and run it. I mean, if you see that fog shooting right back into the living space, or if I'm on the house side of it, if I'm in the conditioned side, sometimes I think it's easier to flip the fan around and pressurize it and watch that fog kind of disappear into the wall assembly. Sometimes it's just easier to see, or if you're trying to document it, to take a picture of it rather than it blowing back at you. But we can test the house in either direction. You can do positive or negative. All the standards will let you do either one. But I always try to go negative if I can, just so I'm not counting leakage from blowing open dampers for bath fans and for kitchen exhaust. But that goes back to some of those first things you want to check. Like if you're checking a home that has a wood burning fireplace, make sure there's no ashes in there. Because if you're going to depressurize that, and you can pull ashes all into the living space and make a huge mess. Been there. It's not fun. Yeah. You never forget it.
I can imagine.
But and the other thing too is, like, why are you there in the first place? Right? Is if there's mold growth, suspected mold growth somewhere along the air barrier, do you want to depressurize and pull those mold spores in? Inside. I mean, sometimes it's a better idea just to flip the fan around and push on it from the other side.
That's what I was going to say is, depending on lead paint, asbestos, you might want to pressurize rather than depressurize.
Yeah, especially those older homes. It's worse to take the time to look around and see if there's any of those hazards there that you want to avoid. Yeah. And then, there's some older homes in some parts of the country where you might have, speaking of asbestos, you might have vermiculite insulation.
Yep.
In the attic. And that's where we recommend not running a test at all. All right. If you pressurize it, you can disturb it and it can fall back down into the living space. I mean, there's arguments to say, well, it could experience high winds and that happen anyway. But don't make yourself a target if something were to happen. So that's where we say, like, look, hit the brakes. Let's get abatement in here to get this done by someone who's certified. When it's gone, then let's come back and resume. But other ways you can kind of work around it a little bit. But that's, when there's vermiculite insulation, I think it's always wise to just kind of stop right there and don't go any further.
Do you ever introduce like cameras to be able to look at different temperature variations within walls?
Oh, absolutely. Yeah. So thermal imaging and blower door testing go hand in hand, especially if the weather cooperates with you. Usually you want to be it's ideal to have at least a 15-degree temperature between inside and outside. I've had 10-degree difference and been able to see what I need to see. If you get below that, sometimes you're just not going to be able to pick it up. And you may not always get that, right? If you're doing like spring and fall, you make it where it's the same temperature inside and out. That's where using, the handheld fog generator or another manometer to probe around with might be a better option. But yeah, thermal imaging cameras, there's so many out there now, and they're moderately priced, especially for what they used to be. And there's some really great options from some great manufacturers. I've been using one, I can't remember the model name of it, but it's one by Testo, and you can clip it to your phone, and it actually has a really pretty good resolution. But what I like to do is detach it, and I'm using my phone as the screen, and now I can just get into tight spots with it, where I can't, fit my body up in a tight spot in an attic or something like that. And so I can have my phone here and look and just kind of use it as a wand. But yeah, that's great, because if you can depressurize when you're depressurizing the house, you're forcing air through the leaks to the inside. And so if you're not running a blower door at all, if you're just walking around doing a thermal scan, yeah, you'll see thermal bridging and things like that. But until you turn that blower door on and actually see that air streak across the surface, that's how you're able to differentiate thermal bridging or something wet versus an actual air leak. So just because you're seeing discoloration doesn't mean it's an air leak until you put a blower door on it to make it react to it. That's how you really pin it down.
Sure, absolutely. Now, are you seeing from the contractors, are you seeing HVAC installation contractors that are starting to spend more time approaching the building sciences, or are you seeing contractors that are becoming more specialized for the actual blower door and duct blasting testing?
Yeah, I would say a mixture of both. We're seeing, especially a lot of the smaller shops. These guys that are really trying to take their time and do it right. You really can't ignore building science. It's part of the puzzle that you have to be able to use those tools to figure it out. And especially, in system change outs in existing homes, a lot of times it is oversized what was there. And so a part of that input to get your manual J is infiltration. Mm-hmm. And I think what happens a lot of times is people just kind of click average and keep moving through it. Where really, if it's extremely leaky, I think for a lot of cases, if you look at what like extremely leaky is for a house, it might be 8 air changes per hour of what it equates to. I've tested houses at 20 air changes per hour. Especially if you're doing like historic homes and stuff like that, you see some off the wall numbers. Or, sometimes average might be too loose. Sometimes that house might be a lot tighter than you thought it was going to be. And so like having an actual numeric value to put into that to make it more accurate is just going to give you a lot more confidence in the sizing of that equipment.
Yeah, 20 air changes per hour. Is the house made of Swiss cheese?
Yeah, man, I think it was balloon framed too. Like it was built in 1875. And the homeowners, they were hell bent on replacing the HVAC, and that was going to fix all of their problems. And we finally convinced them, like, look, we ran a blower door test. Here's everything we found. Like your attic is, until you address that. They had, so many differences in ceiling height where they would have open wall cavities, and they had 4 chimneys that had an 8-inch gap all the way around each one. Wow. And, when you see stuff like that in older houses, like you're not going to get where you want to go until you address that. So
absolutely. Well, very cool. Well, Sam, I really appreciate you joining us today. Todd, great to have you hanging out, just to help shed a little bit more light on understanding, the necessity for looking at your cavity, not just your system, understanding what the entire envelope in that building cavity is looking like. So I encourage everyone, spend a little bit of time getting to know RetroTech a little bit better, getting into classrooms, and adding to your classroom in particularly, understanding the building sciences of what we do. So guys, I really appreciate you joining us, and we look forward to seeing you all. We'll do a show next week live from Ann Arbor, Michigan, and we hope everyone has a good evening. And we'll see you all next week on Did You Know, the ESCO HVAC show. Bye, everybody.
Thanks for watching.